Hey everybody, this is just a quick video giving you an overview of setting up your WindIO NV4 software for iDeck. This is the one that lets us program our HMI. So when you open the software, the first thing that should pop up if you're not opening a project you've already started, it'll prompt you here with this little dialog box to select the model HMI that you have. So just like with our PLC, very important that we select the right model. It's even more so important with this software because it builds the size of the screen based on the model that you select, right? And they're not all the same size. Like this one, this top one here is a 7-inch. And this was one that's actually a 7-inch screen with a logic controller, so with a PLC built into it. We'll use, this model in the lab and the HG1G. This is the one we're going to start on. This is a little 4.3-inch screen. So just look at the device you're using. You should be able to find that product series number and select the appropriate one. You can also choose how you want to install that screen, right? So if we were mounting it into a cabinet door or something like that and we wanted it to be vertical, and then are you rotating it, counterclockwise or clockwise, or if you want it to be horizontal and upside down for some reason, you can at least do that. So these are all the options we want to select. We hit next once we have that, and then we have to select a communication driver. So this is super important that we do this. You can come back in and set it up. It's just kind of wonky to find the right menus, but basically all we have to do is select what PLC are we going to be talking to. So if you have an Allen Bradley device or an ABB device or a Siemens device, right? So if I keep scrolling down, there's Siemens and Keyence and Yaskawa and all these different companies that are pretty common that make PLCs. So there's a lot of stuff you can use with these HMIs. We are going to use an iDeck PLC. That's what we have. And we are going to connect via Ethernet. With ours. So that just keeps the cabling simple. We just need a Cat5 or Cat6 Ethernet cable, and we're good to go. So that's what we're going to use. We're going to say, so we selected iDeck, we selected the Ethernet, right? MicroSmart is our PLC, FC6A. That's our model number for the PLC, and we are using Ethernet. So, okay. And that lets us build our first screen. We can give it a screen number. We can tell it if it's a base screen or a pop-up screen. We're going to start with a base screen. That's probably generally what you're always going to start with. We have we can title the screen, so we can just, call this screen number 1 or our base screen 1 or whatever we want to call it, screen 1. It might be a home screen, right, whatever you want it to be. There's a few other options in here, like what's the background color. Generally, I'm always going to stick with black, and then I can color in buttons and stuff that will stand out well on a black background. Okay, so we'll just say OK here, and here is my screen. So this is kind of actually on my monitor. I think this is pretty much a 1-to-1 scale. That's about the actual size of the of that little 4.3-inch screen. I can zoom in down here in the bottom right, so we can make that bigger or smaller, just to make things easier to see. You just have to bear in mind when we load this onto our device, it is actually just going to be a little tiny screen, so you can't make, if you zoom way in and then make really tiny little buttons, they might be kind of hard to press, right? So those are just little things that you got to think about when you're designing an HMI screen. So this is 100% zoomed in, right? You can see like how little that screen is. So just like with our Wind LDR, our ladder program, we've got a home tab, configuration tab, online tab, a view tab, and now we have a format tab, which gives us some other options for formatting shapes and text styles. I don't generally mess around in there too much. I keep things pretty simple with the HMI design. In our home tab, we have like our download buttons. This lets us download our project to our screen, just like we do with our PLC. We've got communication settings. Now this is how we are communicating to the HMI from the computer that I'm running this software in, right? So it's not the communication to the PLC, it's the communication to this computer, right, that I would be programming with. And we're going to use both USB and Ethernet, so you'll have to come in here at some point and use Ethernet, but we can use the USB cable just like we do for the PLC, no big deal. We've also got over here a project tab, just like we do in our PLC. Like we can see subroutines in our PLC ladder program. We can see our screens, our base screens, and our pop-up screens, and there's a few that are here by default. They give us a few different options, and we'll eventually go through those, but not in this video. So however many screens I have, I'll see them here, and I'll also see the screens appear and tabs up here. So if I right-click on this base screen and say add a new screen, I can say, well, okay, this is screen number 2, and I'm just gonna call it screen 2. Boom, and then I see those tabs up here. Okay, cool, and then I can see it over here in the menu tree. We've got the ability in the View tab to see different tabs, right? A toolbox that gives me some of the same functions I have over here. I've got a part library on the right side. We'll go through all the different types of buttons we can set up, pilot lamps, data displays, right, charts. These are typical things that we're going to include in an HMI, because that is kind of what makes an HMI super useful, right? We can add as many buttons as we need for our system without increasing the field I/O. We can see the status of things. We can use pilot lamps to show the status of things without increasing our field I/O, and we can display data, right? So if we wanted to monitor the temperature of something and had a thermocouple, we'll set that up, and we're able to monitor and display a temperature, right? Or any information that we can get in to our PLC. So all very useful stuff. So you can choose what you want to see, over here. For now, I'm just going to leave it the way it is. I like to see the project tab over here so I can easily get myself in between different screens if I need to. We'll go back home. I've got the ability to open and create new projects. I can add in shapes and pictures and text. So if I select one of these, it lets me drop in a text field where I can type something in. We have different buttons. We have lamps, indicator lamps, data displays, charts, and commands. So we can write to our PLC if we need to change the setting of something, right? And we'll go through how to do all those things. So this is just like the basic layout overview. Pretty similar to our ladder program in the way it's laid out, but we do some different things in here. One thing, let's go through setting up a button real quick. So here's a bit button. So a bit button is, I'll click on it and then I just draw a button, right? Doesn't have to be anything fancy. Hey, it's just a big square. So this bit button is either a 0 or a 1, right? It's true or it's false, it's high or it's low. That's it. That's all it can do. It's like a normally open or normally closed push button, momentary button, right? But we can change the way this button behaves. It doesn't necessarily have to be momentary. We can make a maintained button, like a maintained switch, a toggle switch, a selector switch. We can do some of those. We can control some of those things with this. So if I double click on this, it will open up the properties of this bit button. So here's a part name. I can change that part name to something else. So if I wanted this to control something, maybe I would put that in there, like, oh, this is the start button for our motor or whatever it is. Here's the action mode. So it's going to behave like a momentary button. We can also do sets and resets. Now, if I do a set, I have to have a reset, right? So that would mean I'm really going to need two buttons, one for the set, one for the reset, just like with our outputs in our ladder program. Alternate and toggle are kind of similar, but they do behave a little bit differently. I'm not going to go into the details. But you can always hit F1 whenever you're looking inside of a window, and that's what I just did here. I hit F1, and you can read through kind of what the different action modes do, right? So a set, a reset, a momentary, an alternate, right? So each press of the button alternately writes a 1 or a 0 to the bit device. Right, so it can either be 1 or 0, right? So 1 is true, high, 0 is false, low, right? A toggle inverts the value. So they can behave a little differently depending on what the starting state of your bit is. All right, so yeah, so that's an F1, right? We can always kind of read up on what's going on with all these things. So the destination device address, this is what bit are we making a 1 or a 0? Now, if I'm connecting this HMI up to my PLC and I want to affect an output, say, on the PLC, I want to start a motor. Well, I have to switch the output for the for my contactor, right? And I might have a line of logic in my ladder program that switches the output on and off for a contactor. Well, I can place this button into my ladder logic and affect an output, a physical output, on my PLC device. All I have to do is change this target. This is looking at the internal device, the memory of our HMI, but what I really need to do is look at my external device. The external device is my PLC, and I can have a whole bunch of PLCs connected to this one HMI at the same time. So this PLC, or this HMI, I'm sorry, could be connected to a couple different PLCs, and one button could change something on my first PLC, and then I could have a second button that changes something on my second PLC. We're always going to start with external device 0. We start counting at 0. And then once I have that target as the correct device, okay, this button is going to change a bit on my PLC. Now, the type of bit is it, right? Is it an internal relay or is it an output, right? So there's a few different things we can do. We can affect data registers, timers, counters, a few different things. And we can affect inputs as well, but we're not going to do that in here. We're going to just use an internal relay. And I'll just choose whatever. We don't have anything identified here. We have nothing's been defined, right? So everything is blank. So we'll just use M0 for now. Just as an example, I'm going to set this as a momentary button. And then if I hit OK, there it is. So every time I press this button, M0 on my PLC would go from 0 to 1. It would go high while I press this button, because it's going to behave just like a momentary button would, right? So it's no different than a normally open push button that's wired to an input on my PLC, but this is now associated with an internal relay, M0. So I have I've created like a pretend field device, right? This is a button that I can physically press. It only exists on a screen, and the data that's transmitted is virtual. There isn't like a 24-volt signal getting sent to an input somewhere. It's just changing a 0 to a 1 in the PLC's memory. Okay, so this is the basic layout of this. I just wanted to go do a quick video. We're at 15 minutes, so we're going to end it here. Hopefully you got something out of it, and I will see you guys next time.